This is question 3 from the SACE Stage 2 Physics course companion in subsection 1.1. Here we have a tennis ball being struck from a height of 1.85 meters above the ground. Initially moves at 75 kilometers per hour at 25 degrees above horizontal. Assume air resistance is negligible. First, we need to resolve the velocity into vertical and horizontal components. This is much like what we've done before, except in this case, the only difference is we need to convert the kilometers per hour back to meters per second. So we know that to go from meters per second and kilometers per hour and vice versa, we just multiply or divide by 3.6. So if we have meters per second to kilometers per hour, we multiply by 3.6, and the other way, divide by 3.6. So to work out the initial vertical and horizontal component, we'll do it all in one step. We know that the vertical is v sine theta, so here will be 75 on 3.6 sine 25, which if we substitute in our calculator, we should get 8.8 meters per second. And similarly for the horizontal component, v cos theta, and here 75 on 3.6 cos 25, and that should be 18.9 meters per second. So that's not too bad. Next we have to work out the time taken for the ball to reach its maximum height. So this is a straightforward Vovats type question, so we'll begin by writing out everything we know using Vovats. So our initial vertical speed is 8.8 meters per second. At the maximum height, we know that the vertical speed is 0. 0 in there. The acceleration is just acceleration due to gravity, so negative 9.8, and we're trying to work out the time. So the only formula we have that has all of those in it is V is V0 plus AT, which we rearrange to become V take V0 on A. So 0 take 8.8 on negative 9.8, and if we put that in the calculator, we should get 0.897 seconds. Now I'm keeping this to a larger number of significant figures than normal because we'll be doing a few different calculations. So now we've worked out the time taken to reach the maximum height, we have to work out the maximum height itself. So we have almost everything we need, so just use another formula. I'll use S equals V0 t plus half a t squared. Now just substitute all the values. 8.8 multiplied by 0.897 plus half times negative 9.8 times 0.897 squared. That's a bit hard to read. Let's see if I can fix that. Let's get rid of that whole bit. So 0.897 squared, and if we put that into our calculators, we should get approximately 3.95 meters. Now this only gives us the height from when it was hit, so it's about from here to here. We want the maximum height it reaches, so we need to add the 1.85 meters. Therefore, the max height will be 1.85 plus 3.95, which equals 5.8 meters. So now we've worked out time taken to maximum height, the actual maximum height, now the time taken to reach the ground from its maximum height. This is another VOVATS type question, so we'll write down everything we know. So we're considering the second half of the motion, so the initial speed will be 0. To know the final speed, the acceleration is negative 9.8. We're trying to work out the time, and we know the displacement is negative 5.8 because it's going downwards. So now we just need to use a formula which has S, A, T, and V naught in it. So V naught T plus half AT squared. This one is quadratic, but happily the V naught just disappears, so this will become S equals half AT squared, which means that time will be 2s on A all square rooted. So 2 times negative 5.8 on negative 9.8, which if we put into our calculator, we get approximately 1.09 seconds. So I've got the time taken to go from the maximum height down to the ground. Finally, the total horizontal distance the ball travels. So here we have to add the time taken to reach the maximum height and the time from the maximum height to reach the ground. So the total time of flight will be the 1.09 plus 0.897, which ends up being essentially 2 seconds. Therefore, the distance will be the horizontal speed times time, and we worked out the horizontal speed before. That was 18.9. That remains constant throughout the motion. So 18.9 multiplied by 2 seconds is 37.8 meters, and that is the range of the tennis ball. So there we are. We've done all those parts, and it wasn't too bad. It got a little bit more complicated converting between meters per second and kilometers per hour and having bi-level projectile motion, but ultimately it's not really any different from any of the other projectile motion questions, just it takes a little longer because you have to consider the two halves of the motion independently.